All right, looks like we're ready. It's giving me a little low bandwidth error, so we'll see if it has problems. Let me know, or really bad problems. Let me know. All right, what we're doing today. Actually, first, let's start with our thing we left off with last time. Last time we ran the Fusion 360 generative design for this little bracket. It did finish, and let me find it. Here it is. These are the two, well, you can't see that. These are the two brackets that it came up with. Remember, we had set up this with the green little bar here being the top of the bracket. These two cylinders being bosses around some kind of mounting hole. These red are obstacles that it can't generate any material in. So it had to go around this circle, and it couldn't put anything up above here. And this is what it came up with. It came up with this design, and you can kind of see their progress, how it, well, now I'm previewing it. There we go. You can see, here we go, the process of where it got to this. It's going to take a while to reload. You can kind of see, you can scale it back at any, well, not at any point, but any of the iterations. It looks like it did 44 iterations on this thing. And you can kind of see, let's go to the very beginning. In the little preview box, you can get a better idea of what it's doing. How it basically first put a bunch of material everywhere, and then worked its way to figuring out what part of that material was actually needed. And in the end, it came up with this one being the preferred solution. Now this is in aluminum, so this is a aluminum material, which you can 3D print. You can also sort of see, I made it where it was printing from the Z, like the part is laying down in the bed more or less this way. And you can kind of see that in how it chose to put material. You can kind of see there's a little spot that's probably sitting on the bed, and it added a little bit of support type material over here, and you can kind of get the idea of how it would print. Yeah, I mean, this looks like it would work. It's very spindly, you know. So let's look at one of our other options. This one looks a little beefier. See what it looks like. This is the well, I don't know exactly what material this is, but it's additive and resin type material. Oh, we are getting more network errors. Looks like we're still streaming, maybe a little jerky though. This one actually looks pretty cool. I think if I were to build this, I would take most of this and probably increase this little spinely, this big little tendril that's going up here. I would probably make that a little more intentional. You know, the Autodesk doesn't actually care if it looks nice. It's just, this is what needs to be there for this part to work. And so then it's your job to go in and maybe clean up the part a little bit, you know, maybe just make this entire top part a larger rectangle so it doesn't have these little wings on the side of it, kind of thing. But take inspiration from this. You could print this directly, and it apparently would work under the load that we applied. I don't even remember what the load was now. But there are things that you'd probably want to do if you were producing this for real. Like, I would probably want to do something different with this little piece over here, clean up this top part so it looks more intentional. And then I like this, you know, I don't know, cloth-like ripples you get in here. That's kind of nice. Maybe thicken that up. But you can kind of see how it's working. I didn't time how long it took to generate these two results, but it was hours. I just let it run. Actually, I closed it down. I closed down Fusion 360 and reloaded it today. So I don't even know how long it took to generate these results. And I don't know if it gives me anything like that. It doesn't look, there's probably somewhere that I can go in and see how long these took to produce, but I don't actually know where that is. I've never tried to measure how long that takes to produce these, other than the first time I did it, I just left it running and it was somewhere in the several hour range. But these I don't know. So that's how Fusion 360 can do generative design. It is a cost model. Currently, most of the accounts that I have seen are free to run at least some number of simulations, but at some point, I suppose, and if you're industry, commercializing this stuff, then I'm assuming that those are not free for those customers. But it's a really cool way to generate exactly the material that's needed, or to get some ideas on, well, I could see how I could build something like that from scratch, and then go back into Fusion 360 or your CAD modeling package or whatever, and build something inspired by one of these solutions. So that's a one thing you can do. And for the most part, you should be able to do this as a non-commercial user free with Fusion 360. SolidWorks has its version of topology optimization, and there's not a free version that I know of SolidWorks, but there are some hobbyist type versions. They're not expensive either. I think it's less than $100 a year, I think, something like that. So a couple of dollars a month to use it as a hobbyist level. I don't know how many of the features you have access to, though. I have education licenses for these, so I don't really know what the non-education licenses look like. All right, I'm going to close this down, maybe save a little bit of our processing power. We got a lot of things going on here. What we're actually doing today is looking at photogrammetry. And you can kind of see here a preview of what we're going to look at. There's several of these programs out there. There are many free ones. I think Autodesk probably has. They did at one time. Let's see if they still have one. A photogrammetry software package of their own. I can't remember the name of it, though. Let's see if any of these look familiar. Recap Pro, that's it. So that their version of photogrammetry is Recap Pro. There might be, the Pro means that there might be some other version also. And the idea with these photogrammetry tools is that you take a bunch of pictures, and then it figures out depth of field, and it infers geometry from taking a lot of pictures. I don't know that this one, I have used this one before, so there's a free trial of it, and I don't remember if it's limited by time or function or just the fact that you can't use it commercially. I don't remember that detail, but it's a pretty good piece of software. That's not the one we're going to use because I don't remember if it has a completely free version or not. The one we're going to use is actually over here, called Meshroom. So it's under the alicevision.org heading, and then Meshroom is the piece of software. It works really well. It's free, and it takes in, I don't even know if there is a limit on the number of photos that you can send to it to create the geometry. I did a very small number just on my phone, so they're not going to be ideal, but it does produce geometry, and then you could take the same idea, be more careful with your photographs, and get something more accurate. You can kind of see some examples of the level of detail they've been able to produce. This one actually doesn't look as good as it probably could. This one's a little bit washed out. So what you do, let's go over to Meshroom. Here it is. So over here, you take a series of pictures. I took 58. There's 58 pictures over here. It did not use one of them because it was too blurry, I think. So let's see. This is of a little, yeah, that one's definitely too blurry. So that one it did not use. So we can just remove that one from the list to begin with. And it used these others. And so it used 57 of the pictures I took with a cell phone. And they're just the corner of a little pop-up camper sitting outside. And you take some number. 58 is actually kind of a small number for the number of pictures you might want to take for one of these things. I used a cell phone outdoors and just walking around. So the better you can make the pictures, the better results you're going to get, and the more pictures you take, the better results you're going to get. So things you want to have happen when you're taking these pictures is you kind of want uniform lighting. It doesn't work too well with really reflective surfaces or glass type surfaces. This camper is not particularly reflective, and it doesn't have any glass right there, so those were met. It was sort of overcast when I took the pictures, so there aren't a lot of uneven shadows on it. If you have anything that is changing in the scene, that's generally bad. So if you take some pictures for a few minutes and then wait a couple of hours and take pictures again, those two sets of pictures probably won't work together very well, because the shadow situation is going to be completely different unless you're indoors or whatever. So if you're speaking about if you're outdoors, these things, photogrammetry in general doesn't work very well to get tiny details. So if you want to take a bunch of pictures of a small little statue or something, it will give you a result, but it's not going to pick up the level of detail that you would hope for, I assume, unless the statue is very not detailed. So typically these work better with larger objects. For the really tiny objects, then you can do this, but there are better ways to do it than photogrammetry. There's laser scanning and Lidar scanning. Well, Lidar even doesn't give you that many details, but there's laser scanning and structured light scanning and things like that you can use to get better detail. I will show you a Lidar example, which is not particularly good for small details either, but it's basically if you have a phone that uses Lidar. A lot of times if you have a face unlock phone, it's using Lidar, and so that can add an app to that phone, and instead of using that to scan your face to open your phone, you can scan whatever around you. It doesn't get super tiny details, maybe a centimeter, maybe some sub-centimeter level, but not like a millimeter necessarily. But you can get some kind of details. And I'll show you one that I did of this same camper using Lidar. I only did the corner. I wasn't really interested in trying to capture the entire camper. I just wanted to show you the process of it. So what you do is you load up your pictures, and with Meshroom, it is down here in this graph editor is what they call it. All these little blocks and nodes. You can kind of see, if you've ever used LabVIEW, it kind of looks like that, where you've got these blocks that are connected together with these little lines that are showing data flowing from one point to another. You can use it exactly the way it comes out of the box. Just drop the pictures in over here, and then click the start button, and those settings are generally fine. It takes a while. It takes, I don't know, I would say with the 57 pictures that I have, it probably took, it's under an hour, over 30 minutes, under an hour, somewhere in that range. More pictures, it's going to take longer to process. And there are some things you can do to speed up the process, but the default, this little chain of commands that it's going to run through, it does generate a pretty nice mesh. Here's what mine generated. If I click on this texturing button, it'll, well, why is it not showing? Let's see. I don't want to recompute it all. But it's definitely not showing our results right now when it should be. It's actually not showing any of the results. I wonder if that has to do with screen capturing of this thing, although everything else seems to work normal. If I hit the start button, it's going to take a while to scan. Let me make sure before I do anything that's going to make us restart. Like maybe it's off the screen or something like that, because it's not even showing. There's where it would be. Yeah, I don't see where our geometry went. Although it has already created the geometry, we can look at it in Mesh Mixer, something like that. It already has the, like if we look at our mesh right here, we have a mesh already generated. But for some reason, we don't have it showing up. I'll click start and we'll look and see what process it goes through. I wonder if I disconnected something accidentally by moving them around. I don't think I could have. You have to click on them and remove them. Well, we'll just start this and let it go. So it starts way over here, gets all the cameras. I wonder if erasing that one picture that didn't use kind of reset it. That shouldn't have, but maybe it did something like that. And so what it's doing right now is it's going in and taking a first pass at trying to align and figure out where all of these cameras, well, it's one camera, it's my phone, where all of the phone positions were to generate these pictures. So if you can get your images nice and sharp, and they are various different positions of the object that you're trying to take pictures of. It doesn't actually work if you take multiple pictures of the same spot very well. So you move around. If you were using a tripod, that would be better. High shutter speed would be good if you're not, so that it doesn't have a lot of motion blur in it. You don't want to change any of your camera settings during the process, because you want the pictures are actually going to have metadata from the camera that you used embedded in them, and Meshmixer is, or not Meshmixer, Meshroom is going to read that metadata and infer settings that you know, what were all the settings of the camera when it took this picture. It doesn't use any sort of tracking, so it doesn't like know the position of the camera. It figures out where the camera must have been based on the series of images that you gave it and how they would fit together. So it looks for identifying features and tries to find those in each image, and you know, figure out, okay, if the camera was here when it took that picture, and this little stripe is right here, when we move over here, I see that stripe again, and now the camera must have moved a little bit to this position, and so it does that iteratively. That's what it's doing right now. Well, part of what it's doing right now, and it will do that to figure out all the positions of the cameras, and it'll create sort of a point cloud, and that's where once we get to this structure from motion node, well, I don't know if this is called a node. I think the individual parts are nodes, but anyway, this block, once we get to there, we'll have kind of a point cloud of things. This step right here, prepare dent scene, that one is where you may have, that's where it's going to slow down. It's going to bog down. In fact, this part right here, the depth and prepare dent scene, these things, these three, are only going to work if you have certain video cards, NVIDIA video cards in your computer. If you don't have an NVIDIA video card, I think the current state of Meshroom is that it won't do these parts, because they're super intensive on processing, and I think they rely on the NVIDIA CUDA processing to do these three. You can skip these, so you could break out, you know, and bring another, well, basically meshing block over here, and just plug in the structure for motion into that meshing block. In fact, maybe that's what we could do to speed this up, is maybe we could just do that, and that would show you kind of how this works. We're going to get a really bad mesh if we do this, because I only have a few pictures, and the dent scene is where you really get your data. So if I skip it, then it's faster, but I get poor results, or not as good results. In fact, with this one, I probably wouldn't get much at all. I would get just a tiny corner of the of the camper that I was trying to scan in there. I would just get, let's see, I don't even see one that kind of shows what I would get, you know, just this little piece over here is all I would really get, because that's where I kind of centered everything. Let's see where we're at in our chain. All right, so we did our feature extraction, image mapping. Now it's trying to go and match up features. So it's looking for identifiable, might look for this feature and find it in multiple pictures and, you know, figure out where these cameras are. So it's doing that right now. Once it does that, that's when we'll get the structure from motion. Once it completes the structure from motion block, we'll actually have sort of a preview of what to expect. I'm going to cancel these so that we get new ones. We'll get a point cloud, a colored point cloud that kind of gives us an idea of where all the data that it has identified it predicts it to be. It won't be much of a mesh, or actually won't be a mesh at all. It'll just be dots on the screen, but it gives us a preview of where it's headed. And then the structure from motion part is going to be the lengthy, time-consuming part. Since I already have done this exact one, this is the default set of nodes and blocks with their default settings. I've already ran through that. We can open the results in Mesh Mixer, which I think I already have open. Yeah, here it is. And here's what we get in Mesh Mixer. So you can kind of see this is the data from the output, the mesh, and it does create a texture file. Obviously, you're taking pictures with your camera, so it's going to have all that material and texture information that it will also map to your geometry that it produces. I don't know how to turn the texture off in here to look at just the mesh in Mesh Mixer. I'm not actually sure how to do that, but we could probably do it this way. We could probably export this as an STL, which doesn't have texture data, and then reload that and see what it looks like. Because all right, so it's saying that it's non-manifold. In fact, let me show you that. If I look at the back side of this, it's hollow. There's nothing there. So it is just a shell. So you actually have to go in and figure out, you know, how you're going to make this a solid if you want to print it. Either that or scan all the way around the thing so that the shell encloses it. And then there is a make solid button. Yeah, it is awesome. It's really cool how it can just take pictures and create some really interesting geometry. Last year, one of the students, I don't know how many pictures they had to have taken to do this, but they used Meshroom, and I don't remember Ray-Bans or some sort of sunglasses, and they were able to reproduce the geometry well enough to print a second copy that was really good for FDM printing from a scan. It actually was quite good, so it was surprisingly good. Let's see if we can find out what our geometry actually looks like here. Oh wait, I never exported it because it said it was not manifold. Let's do that anyway. I don't know what it'll end up with since it is just a shell, but let's see what it does. I don't know. Let's continue. We could try repairing it. I'm afraid Mesh Mixer would take a long time to do that though, so we're going to replace that one. And we put it in, I think we just put it on the desktop. There it is. Actually, we'll get a little preview here, won't we? So there's the actual geometry. Let's open that and see what it looks like up close. If it will do that in any reasonable amount of time. These meshes do end up with millions of vertices, and so they do take a lot of processing power to deal with. But that's the geometry. You can see where it's, you know, it's cheating here. It didn't really pick up much of the geometry on those two, that latch and that little side marker light. but a lot of the geometry is there. When you put the texture on top of it, you can see some ripples in here that it couldn't figure out. When you put the texture on top of it, it looks, like it's perfect, but the underlying geometry is not perfect. At least not with this number of pictures that I took. But it's there, and you can use it to do some baseline modeling if you wanted to create something. Maybe you want to create a thing that goes on here or interfaces with these shapes. Then you have something to work with, just versus trying to go out there and measure all the points and do something like that. You can get something to work with this way. So it does take a couple of, maybe an hour. Maybe by the time you took the pictures, imported them, ran the software to get the mesh, brought it over to Mesh Mixer, you're probably 2 hours in at that point. To get to that point so that you can do whatever modeling you want to do off of that. Let's check on where we're at right now. Let's see. It's still in the feature matching mode here. Now I do have a lot of stuff running, so not every bit of processing is going to Meshroom right now, but it is working. I will mention also, I think I mentioned it last time, maybe that was the other class, I don't remember. If you're doing this sort of thing, SolidWorks simulations, Meshroom. Here, Meshroom does not load these to the cloud. I think the Autodesk one might load stuff to the cloud and process it there versus locally. If you're doing any of this stuff locally, these heavy, intensive things, and you're on a laptop, be sure to plug the laptop in, because most laptops, unless you've gone in and changed their power management settings, when they're not plugged in, they are not going to run the CPU at 100%. They're going to run it at like 50% usually. So they're going to throttle it down just to save battery life. So you either have to change the power management to where it never throttles, or plug it in is the best thing, because it's going to eat through the battery really quickly if you don't throttle it down. So you will get these things done faster on a laptop if it's plugged into wall power. Hey, all right, so we've got our structure from motion, but I don't see it. It's given me the icon for it, but it hasn't actually shown that it's complete here. Maybe it's just preparing me. We'll come back to it in a minute and see if it's actually created the structure from motion, because it does give you a preview of what it's going to do. I did, like I said, I have an iPad that does have Lidar on it. I don't have a phone that does, but my iPad does. So I used an app on there that takes advantage of the Lidar from the face recognition. Actually, on the iPad, it's on the back part of the eye, so it's not facial recognition. It's just a Lidar scanner out there. And I did the same corner of the camper, and this workflow was, I don't know, it may not take 5 minutes maybe. So you just turn on the app, point the iPad at the thing you want to scan, hit record, and it will give you a preview of what you're capturing. There's some settings, like you can capture how far away are you going to be and what level of detail. I think the lowest it can go is 5 millimeters, and even then it's not really 5 millimeters, but that's what it says. And let's load up what that looks like. So here's the data after an hour or so, well, capturing and processing, maybe an hour and a half, 2 hours, that we get from Meshroom. Now, I will say that more pictures for this would make it much sharper, and if I was more careful about taking the photos with high quality photos versus just a random phone moving around taking 50 pictures, then we could get, let's open, I'll probably have to import it. Let's import, replace this one. I don't think I want them both on there at the same time, although that might be interesting. I think I put it in here. So this, no, that's the one. That's not it. That's the one that's from Meshroom. Let's get the right one. Where did I put it is the only problem. That's the one we just saved. I might have to... That one's a long time ago. Let me check. Let's go over there for a second. Let me check and see if I can find where I put it. I think I emailed it to myself so I can... I don't want you to see my email. Here, you can just watch. Actually, I'll just pull that out. You can look at that screen for a while. Or we can go back and you can look at where this thing has made it. It's not a lot to look at there, but it is processing. All right, here's where well, maybe the one I showed you was the output from there. That might have been the iPad output. Well, then let's find what the, because that is the name of it, Untitled Scan. Very, very interesting name. So I think the one I was showing you, I think this is the iPad data. So let's actually try to find the data from Meshroom. So it would have been in, I put it in here. There's the Meshroom cache. Meshing. All right, I've done several of these. So let's see, it's one of the older ones. This one from yesterday. Oh yeah, here's the one from Meshroom. So let's see what it looks like. The iPad also textures because it's also using the camera to take pictures. All right, here, yes, this is the one because I didn't have nearly as many good pictures. So the places I focused mainly on this corner, and it did pick up more data. You know, I can see the latch and the other things, but it is more. There's a lot of roughness to it. I didn't take many pictures at all of the top, and so it didn't know what to do there. And so you can kind of see there are advantages and disadvantages. I get more detail, like you can see the little ridges in here where in the mesh data for the Lidar scan, it's much smoother, but none of this detail exists. But the roughness of this one is pretty extreme. You know, if you zoom out, then it kind of looks good, but you zoom in and it's, you know, there's lots of little rough items. Now, this is textured on here, so there is some actual roughness on the camper shell. I'm trying to get this to rotate the way I want it, and it's not at all behaving. It even has a hole in it over there where it didn't know what was going on. So more pictures will give you better data. Flat surfaces tend to always have a little bit of noise in them. There are, over in Meshroom, there are like ways you can smooth it out. In fact, I could smooth it out here. See if I did, I guess if I did, what's the easiest way? Select. Actually, we could just get rid of a bunch of it. So just get rid of a bunch of the parts you don't need. I'm just using select and hitting delete here to kind of go through and get rid of a bunch of the really bad parts. There we go. So you could go in and you could clean it up. You could spend as much time as you wanted to trying to make it better. The biggest thing that could make it better is better pictures to begin with. And you know, trying to take each picture in a consistent way. A tripod helps. I think I said that. And you can end up with some fairly accurate, although noisy, geometry. I think it's in the sculpt, just where there's a smooth brush. There's a shrinking smooth. I think if you just hold down, shift switch to smoothing, and so you can go in there. And now it's going to be really slow because of the number of vertices you have, but you could go in and smooth things out a little bit and spend as much time as you wanted to trying to, create something that looked more like what you were expecting. Now, since this is a super high density mesh, you can actually create a lower version in Meshroom itself from the original data. I think I don't know if I can show you that process. I can show you how to make it work, but since we don't have any data right now, it's still processing it. I don't think I can actually do the process. But so you can begin to smooth it out and get better looking results than what you start with. Mesh Mixer itself, I believe, does go in and have a way to reduce the number of elements in our mesh, now that I think about it. So you probably could reduce it some here, smooth it a little bit, and then this isn't, when you're smoothing like this, it's not actually reducing the number of elements, which is not helping. It's just making them more flat wherever you paint over it. But in the edit, I believe it is. Well, I'd have to go and see exactly where it is to go in and make it fewer elements. But you can get some reasonable, this being untextured, this actually looks decent for a couple of pictures that you took. Let's see where we're at on our, it's generated. All right, so you can get an idea of it. So it's done the structure from motion. And if we make this a little bigger, you can kind of see what it's doing. So all of these little, these little things, that's where it has figured out cameras must have been, or the camera must have been when it took one of these pictures. So each one of these represents one of the pictures I took. Let's turn off turn off the grid, turn off that. So you can begin to see where, I didn't take many pictures that show this area. It's kind of blank there. It's going to figure out some of that, but there is a hole there when we looked at the mesh. And there's almost no pictures that represent the top. Got a couple of little points here that it picked up. And so that's why it's so rough on the top of our model. And the best area is kind of right in here, although it looks like there's a lot of pictures taken over this, but they're not giving it a lot of data to work with. And so you can kind of see where it will head. At this point, if we look at our little tree, it is doing, actually it's done the dense scene, and it's working on the depth map. So it's already finished with that process. I don't know how long it's going to take to do the depth map. That is the really intensive part. So this little block right here is going to take the most amount of time of all of them. But you can see where there's potential to get some geometry that would be difficult to capture another way. It's really good if the geometry is not made up of flat surfaces, because it does introduce noise into all these surfaces. So stuff that's already organic shaped does really well with the photogrammetry. And larger. So larger, like you want to do a statue or something, then it works really well to create some geometry because you're not expecting it to be flat surfaces everywhere. If you do have something that has a reflective area or a glass area, if you can, then paint over it. Probably most of the things you're going to scan you can't just paint over. but you can put something like talcum powder or something just to make it not reflective or not transparent temporarily, and then that will give you a better picture to work from. The reflections really mess it up. Transparency really messes it up because there's an actual surface there, but it sees through it, and so the whole point of the photogrammetry is that the photos are being used to recreate the geometry, and if they're misleading, there's a surface but you can see through it, then the software doesn't know how to deal with that, and you get really bad results in that area, or it won't figure out what to do and it just ignores that picture to begin with. So that's what it's going to do. This is one of photogrammetry or any kind of scanning. If you happen to have one of the phones that can do Lidar scanning, then that's fine. It's just, there's only a select few of phones that can do that. These are one of the optional assignments you can do, is do one of these processes and try to print the resulting object. You will probably have to go into something like Mesh Mixer and make it solid. Remember, this is actually hollow in here, so you're going to have to make it solid, which there is a make solid somewhere in here where it makes solid. Now, I don't know if I click this to make solid, it'll probably not be exactly what you want, but it will make it printable at that point. And it actually smoothed it out some in general. And so it just kind of put some random blocks on the back. You definitely want to clean that up. But what I would do is I would make solid and then do my plane cuts over here. And you could use the plane to, or do like I was doing with the lasso. So you could go in and make it flat. Except that's cutting the wrong way, isn't it? Do something like that. And now you've got a nice, well, we have to make solid again. I guess I cut the edges off of it. Or maybe I never select, that's what I never did. I never actually approved the make solid function. So it does take some, typically it does take some post-processing, there we can accept it, some post-processing work to get this to be a usable thing at all, but it is something that you can do. I guess whenever we cut it open, it undoes our solid. Maybe we'll get a better solid now. Let's see. I'm not really interested in printing the corner of this camper, but let's just see what it does. That's better. So it would take, and it's got this weird stuff up here still. But you can kind of see some of the workflow that would be involved. Again, more pictures gives you better results. We don't need to save that. Evenly spaced pictures. It is possible to use like a turntable if you have a smaller object and put the object on there and rotate it around. I've never found that to work as well as walking around the thing that you're trying to take pictures of. And in general, if it's a larger object and not one that has lots of flat, smooth, shiny surfaces, then you'll get decent or better results. And actually, when you put the texture map on it, they actually look really good. But if you were to print that, they're not going to look quite as good as what it previews, because you can't print the texture map onto it. You just print the geometry. I'll let this go a little bit. We're almost done. I'm going to get up to date on what else we're doing. I think I mentioned this last time. Clipper. I think I am going to do a video on installing Clipper, just so that we can get to the input shaping idea of Clipper. So Clipper alone, again, what it does is it's its own firmware that's going to reside on a Raspberry Pi. We already have a Raspberry Pi. And so I'm going to put Klipper onto this Raspberry Pi. It will take over all the processing of the G code that it receives and all of the figuring out what commands to send. The board in the Ender, which currently it has the SKR board in there, the Mini E3 board version 2, it will basically just be in charge of sending the commands to the stepper motors. This will even improve the SKR. The SKR is a 32-bit board, but since the board will not need to be doing the processing, it only needs to do the transmit commands to the stepper motors, then it will be able to go from, I don't remember, 200,000 steps per, what is that? Is that per second? Maybe? To like 600,000. I'll have to look at the exact numbers, but it will even be able to speed that thing up. It makes a much bigger difference if you're talking about a really old board, an 8-bit board or an old Ramps board or something like that. I don't know why you would have one of those boards. You might have an 8-bit board if you bought an Ender 3, plain Ender 3. You might have gotten an 8-bit board in there if you bought it a while back. This will definitely speed that up. But it does some other things too. So we're going to choose, if I can get it to download, we're going to use the Fluid web interface. So this is, we're not going to use Octoprint. So we will lose some things that Octoprint did. Like Octoprint had Arc Welder plugin. It had the Octolapse plugin and a whole suite of plugins. We're going to lose those, but we'll gain a direct interface similar to Octoprint. And this is kind of what it, oh yeah, you can see that. That's what it looks like. The problem is I'm trying to download it over here. Yeah, over here. And it keeps timing out on me. And that could have been because I was having network issues to begin with. You can kind of see down here, I've tried twice. And it gives me a network error about, I don't know, 15 or 20 times. And then eventually it just gives up and says, no, you're forbidden to look at that. So I need to download this. Or, well, I don't need to. This is one way to get it set up. So this Fluid RPi is Raspberry Pi. This will be able to be imaged onto an SD card using that same Raspberry Pi imager that we used for Octoprint. We can put this on there and it'll be mostly set up. We need to configure some things, but it'll be mostly set up. So I wanted to do that next week. We should be able to do that Monday. I don't think that's what I have written down for Monday, but we should be able to do that for Monday, assuming I can get it. Yeah, I just had Slicer. There's not a whole lot that we haven't talked about. There might be a few things, and if I think of them, then we can talk about those also. But I kind of want this day to be Klipper. Yeah, we've already talked about that. So I'm going to switch this over to Klipper. It'll run on any of the Raspberry Pi, so you can even run it on the Raspberry Pi Zero. If you do the Zero, you kind of lose the ability to also do Octoprint on there. So you kind of need to use Fluid, or there's another one. Can't think of the name of the other interface that is specifically made for Klipper. Fluid is the one we're going to use, but there is another one too. I can't think of the name of it. And you'll also lose the webcam ability if you're doing a Pi Zero. So Pi Zeros are much cheaper, and they will do this, but you probably won't be able to do the webcam, and you will need to probably, well, will probably, I guess is kind of ambiguous. You probably need to use the Fluid interface and not Octoprint, because Octoprint on a Pi Zero is a little bit sluggish sometimes. But we're going to put it on a Pi 3 that we already have for running Octoprint. And this will give us some new features. So assuming you have a Raspberry Pi handy, then you could do this too and have these same features. One of the big things it'll let us do is that it has a separate configuration file. It's not the entire firmware, but a lot of the things that we would normally have to modify in Visual Studio Code and put on our SD card to change the firmware to change those things, we can change with this configuration file without doing any of that. So that's one big benefit, is that we can make changes much faster and iteratively if we are using Clipper versus what we've been using, something on top of Marlin. The other thing it'll let us do is it will give us access to the input shaping, which is where we can account for trying to print really fast, but the faster we print, the more ringing we get, or ghosting. And it will let us, the input shaping will let us process that to smooth out some of that ringing and account for it. Basically try to move in the opposite direction whenever we know it's going to ring in one direction. And so it'll let us do that also. It'll take some tuning, but it'll let us get there. As far as I know, input shaping only exists on Clipper. And it can't even run on a board by itself because it's too processor intensive for the current printer boards, like even the SKR and the 32-bit boards couldn't do input shaping. And so the Raspberry Pi is basically just a computer, standalone computer, and it is capable of processing the input shaping commands to send to your printer. So that'll be our goal on Monday, assuming I can get this to download. I assume that if I just try a different time of day, I'll be able to download it, or we'll do it the longer process where we, I would rather just do this process where it's all built into one file. But if we have to do it step at a time, then we'll do it that way. So that'll be Monday. We're getting pretty close to the end. We have, what? 2 weeks. We have 2 weeks of stuff left. So make sure that I've started going through trying to grade as many of the turn-in assignments that you have. Quiz 2 is still open. I believe it should still be open. And it has 20 questions on there. Yeah, I've got it set to close, and nobody's done it yet. So don't forget to do Quiz 2. It has some G-code questions, so you probably want to have something like the Marlin G-code reference open to be able to answer those, unless you just remember all the G-code. And then most of the other content is from since Quiz 1. So it's these topics since Quiz 1. There might be some things that actually get pulled back from before Quiz 1, like troubleshooting type topics, but those kind of apply all the time. But there are some G-code things, so be ready for that. And you've got until August 3rd to finish that. And then we're getting really close to the end. And if you want to have a specific thing that's not shown on here, then let me know so that we have time to put it in there. And any of these can come out. I probably will keep in the printing with flexible, because we haven't specifically talked about printing with things like TPU on an Ender 3. And that's an interesting thing, that assuming you have some filament, you can actually print rubbery parts. And so that's pretty interesting. So we'll probably keep that one in. We'll keep Clipper in. Some of these others, though, we definitely don't have to keep in, or we can add to them. I did get, or I haven't gotten it yet, but I did decide to do the Voron V0.1. So I have those parts. We have to print the ABS parts, all the plastic stuff. We got to start doing that. I don't think it's all going to come in and get printed in time to actually have this ready for before this course ends. But we keep the Discord running, and I don't ever remove you from the you can remove yourself from the Discord channel, but I don't remove you or shut it down, so you can see things as they happen over there if I don't get to any of this and you're interested in it before the quarter ends. All right, we will come back on Monday. Yeah, thank you. You're welcome. And we'll talk about Clipper and any other things that you might be interested in. And maybe if anything new has happened, we'll talk about that too. But I plan on talking about Clipper. All right, we will see you Monday.